Okay, so this is use ratios in right triangles. It's that first section, I believe, for one of your assignments. I want to make a video on solving a couple of these. All right, use one of the triangles above to approximate EF. So I'm going to go ahead and draw a little picture of that. Something close to it, doesn't have to be perfect. All right, side length 6. All right, so I've got that drawn. Oh, actually, I need to open that up. There we go. So I've got that drawn, and EF is that side there. What's this other one? D. All right, so I need to go up above and find a triangle that would be similar to that one. And it's going to be this first triangle because it has the same angle measure, 20 degrees. All right, I'm going to draw that one as well. Okay, 9.4, 3.4, 20 degrees, and a 10. All right, this should be enough. Because there are similar triangles, we can write a proportion to solve for EF. All right, so notice that this side here, ED, is our hypotenuse, and so is the 10. Now, I'm not going to be able to use that because I don't know the hypotenuse on this side. So what I'm going to do is I'm going to use this longer side, the FD, or the one that's adjacent to 20. So I'm going to say 6, the ratio of 6 to 9.4, again, it's the one that's adjacent to 20, the longer leg. The ratio of 6 to 9.4 is going to be equal to the ratio of EF, all right, EF, EF to 3.4. So it's like, long leg to long leg is going to be equal to the ratio of EF to 3.4, short leg to short leg. Okay, that's one way that you could have set this up. There's other ways you could have done, long leg to EF is equal to long leg to short leg. You could have set it up that way. But now we're just going to solve this using, a little cross multiplication here. Actually, I'm just going to multiply by 3.4. 3.4 on both sides to cancel those out. 3.4 to cancel those out. You could have cross multiplied. That would have worked too. So on the left side, I'm going to get my answer. So it's 3.4 times 6 over 9.4. 2.17. So that's my answer. 2.17 looks like option A. There we go. All right, yeah, this is the one that's a little bit weirder. All right, what's the question ask? Use the table to approximate GH. So first, I'm going to go ahead and draw a little picture of it. All right, H is there, G is there, I is there, 65 degrees. Okay, so I got my picture, and we're trying to figure out GH. Now, the only thing they tell us is that this angle is 65. I guess we could deduce that this angle is 25. Yeah, 25. But anyway, I'm going to use this and this table up here to somehow magically solve this thing. So I think it's obvious we're going to be dealing with this 65-degree column, but we got to know which of these to use. So here's the way you think of it. You have the side that's adjacent to 65 degrees, so the 3, and you also have the side opposite of 65 degrees. So I'm gonna set this up as opposite over adjacent. All right, I think opposite over adjacent. Yeah, here's the opposite over adjacent. they don't have adjacent over opposite, so I had to set it up like this. So opposite is going to be side HG, and adjacent is going to be the 3 here. All right, so this is opposite over adjacent is equal to HG over 3, but opposite over adjacent for a 65-degree angle is equal to 2.14. So this is equal to 2.14. I'm just going to kind of forget about that for now. And now we'll just solve this. So to solve for HG, I'm just going to multiply by 3 to cancel out those 3's. So 2.14 times 3, and you get 6.4. 6.4, there it is. Boom. Wasn't too bad. All right, I think that's good for this video. The rest of them are kind of like that.